Welcome to our initial tour on how to get going with the CS548. After you've unpacked the CS548, install the application using the USB stick that comes with it. Don't have the CS548 plugged in at this time. Wait until the drivers have installed. Connect the USB cable and then turn the CS548 on with the power button on the bottom right hand side. Start the application by running Cleverscope 4 x64.exe, which should be in your start menu. This is what we should find. We've got 5 displays. They're the control panel, the scope display, the signal generator, the signal information, and notes. Let's start capturing the signal by clicking on the auto button. I connected the signal generator output to channel A, and that's what's being displayed. There's 4 channels available. The signal generator is controlled by the signal generator control panel. We can set the base frequency to anything we like in the range from 0 to 65 MHz. I'll make it a kilohertz, and I'll make frequency range to 1 MHz. We can sweep the frequency like this, and we can set the amplitude like this. Just for the moment, we will turn off the other channels on the scope display and just concentrate on channel A. And you do that by clicking the button next to the channel name. Now we just have channel A visible. This is a good way of decluttering the graph. A quick way of getting the channel to fit is to click the amplitude fit button. We can zoom in on the display by using the zoom in button on the time axis, like this. The scroll wheel acts as a virtual knob, so we can see individual cycles. We can zoom back out again, like this, and we can stop capturing by clicking auto. After capturing, we can still zoom in and examine the waveform. We'll click fit to get us back to where it was. We can label the graph by overtyping the A with something else. I'll go siggen. Enter. When I enter siggen, you'll notice the axis changes to siggen, and down here in the signal information, which shows the parameters of the graph, the label is siggen. You can see a number of parameters there. I'm going to do a single capture now. I'll disconnect signal from the channel, click on single, plug it back in again. We can zoom with a number of tools. The first one is that we can use the expand button on the x-axis to find something that looks interesting. We can also drag this signal around like this. We can use the magnify tool to look at something like that. We can use the history to go back a bit. We can magnify in that direction as well, and that direction. In addition, we have some keyboard shortcuts. Let's display them. Help, about, Cleverscope. The ones I'm interested in are control up down for zooming the Y scale on the tracer, and control left right zoom X scale on the tracer. The tracer is this black blob here. If I click and make a marker, number 1 in this case appears on the graph. Its location is shown up here in the graph information area. I can make a second marker by clicking 2, and therefore I can measure the voltage and time difference between the 2 markers and look at the inverse of the time, which is the frequency. Now, I mentioned that we have control left right, so I'm going to go control left, and I zoom out in time, and control down makes it smaller in amplitude. Now, the reason for the keyboard controls is it means that you can zoom and pan on a single location where the tracer is. So that location there, for example. This is quite a fast way of getting around a graph. Click Fit again to get it back. Use history to go back to where we were. You'll notice that when I put the cursor over an object that we get a tooltip. You can use these tooltips to find out what each of the controls does. In order to be able to stop the tooltips from interfering with this video, I'm going to turn them off. You can do that in Settings, Display Tooltips. Actually, settings are used to set quite a few things. So go and have an explore and see what they do. Let's explore some of the other capabilities of the scope display. Just go and zoom in here using the control characters. We can place an annotation on the graph. Let's do that by clicking the annotation tool and choosing the location and then giving it a name. Call it first peak. You can locate the text anywhere you like. It has a little handle like this. We move the graph around. The first peak label stays attached to it. So fit again. Another thing we can do is label the graph using the channel name, which is SIGGEN in this case. We do that by going label track, and now it will track the plot as it changes. This is quite useful for documenting multiple plots at the same time. If we want to copy and paste, we can open Word and click on a display, go copy, and then go to Word and paste. This is very handy for documenting as you go. Now I'm going to display a few more channels. Let's turn them on. If we hold the Shift key down and click Fit, they all get fitted to the display, no matter where they were. Now I'm going to connect some signals up and go auto. And again, if we hold the Shift key down and go Fit, they all come back. Over here on the SIGGEN, we can control the output labeled probe comp. The default's to 1 kHz, but let's make it 100 kHz. If we just capture this, we can read in. We can see the probe comp output in relationship to the other signals. Notice that we can add labels for all of the displays, like this. We can set the label position by using View, Channel, Graph Channel Labels, and then set X-axis offset, like this. Quite useful if you're trying to position the labels in the right place. We've got 3 channels showing information. Sometimes it's useful to have more axes. So let's go and place a couple of axes. On the right hand side, let's have channel B and channel C. But we'll have 2 axes on the right, like this. So now we can see all these axes at the same time. Now, another thing that might be useful, you might want to record the setup for this display. You can do that using the F1 to F4 keys. If I hold the Shift key down and go F1, it records that setup. Now let's make a different setup. We can change the size of the graph by dragging it out. Okay, and we can use volts per division on a normal scope. Let's do this and then move this up, and let's do the same with the probe comp and move that up somewhere else. And we like this setting, so we go Shift F2. Now if we want to go back to F1, we click F1. And if we want to go to F2, we F2. So we can make it very fast to move from one setting to another one. We've got up to 4 setups. If we save this graph, I'll do that right now. If we save this graph by going File, Save As, and we give it a name, here we are, we can type in training signals. We can go and catch some new waveforms now. Let's do another single trigger like we did before. Now let's save this one. So we've now got 2 signals. We can open the first one. You'll notice that is there, training signals. And the second. We might not really need notes right now, so I'll get rid of it. And I could make this the third setup. We'll make this wider again. And let's zoom in on this part here. I'll make that a third setup. So we've got this setup, that setup, and this setup. Very fast. And they're recorded when you save the file. Now let's talk about triggering. Let's capture stuff continuously. We'll remove channel B and D. We don't need them. We'll just use these 2 for the moment. The first one, channel A, is a signal generator. Let's just go a bit wider. We can see the trigger point at time 0. Period before the trigger is called pre-trigger, and the period after the trigger is post-trigger. You can set the trigger level either just by typing it in, for example if I type 0, or you can use a trigger tool. Here's a rising edge trigger tool, and you can just click or you can drag like this. If you go above the trigger point or below the trigger point, it stops capturing. If you use the inverse trigger tool, falling edge, it's now on the falling edge. If I stop using the trigger tool, I can use the slope button to change the direction. The CS548 has 2 triggers. Let's try using them. Firstly, let's change the triggering on channel C. So we change the channel to channel C. Now we're triggering on probe comp. I'll make this about 1 volt. 2 volts will do. At the moment it's a negative trigger, so we'll change it to a positive edge trigger. Over here on the probe comp control, we can vary the pulse width. Currently it's 5 microseconds. You can change the value on the control by placing the cursor after the digit you want to change, and then you can use the scroll wheel to increase and decrease it. So you can see that I can change the probe comp pulse width this way. I'm going to trigger on this. We do that by using a second trigger, which is trigger number 2. If you want some help on this, click on trigger 2 and then click the question mark, and it gives us trigger 2 setup. We can trigger on duration, on counting the triggers, and we can also trigger on a combination of duration and count. And we can OR the triggers, which is quite useful sometimes if you want to trigger on A or B. In addition to this, we can set what trigger 2 will be. It can either just be trigger 1 inverted, or we can make our own definition, which can be anything else. So for example, one signal could be chip select and the other trigger could be data. And we trigger when we get a chip select followed by 16 counts of data. But in our case, I'm going to trigger on trigger 1 inverted, which means that the trigger is now the falling edge on probe comp at the same level, which is 2 volts. Let's trigger on trigger 1 to trigger 2, duration being between between a range, min to max. At the moment we've got 10 microseconds, and we'll make the maximum 6 microseconds. Now at the moment it's not triggering because the pulse width is 1. So we'll increase this. Now it's triggering because we're over 3. We carry on. We have to have the signal on the screen, otherwise it can't see it. So there we are, we're triggering because it's less than 6. We've got one more. It's no longer triggering because now it is more than 6. Less than 6, more than 6. We can also use triggering to trigger on slope. Let's go back to channel A and have a 0 here. Set this to none. Let's trigger on slope. First of all, we place markers on the waveform so we can see the levels we're going to use. Let's have marker 1, I'll type 1 at that point, and marker 2 at this point. I'll stop it now. So marker 1 is minus 580 millivolts. Minus 580 millivolts. Marker 2 is 752 millivolts. That'll do. We get back our trigger 2 source, but we're going to change it to trigger 2 definition. Rising edge, channel A at 752 millivolts. Right, the period at the moment is 230 nanoseconds. So let's make a range, and we'll go from 100 nanoseconds to, let's say, 400 nanoseconds. In this way we're going to trigger on slope. This could be useful, for example, for checking that the slope of a gate drive is correct. It's triggering at the moment because we're in the triggering range. Now let's vary the frequency, which will vary the slope. I might need to make this a bit bigger. 5 megahertz. So I'll decrease. Now it doesn't trigger. The positions of the markers are changing, of course, because the frequency of the waveform is changing. If we were to go and work it out, let's see, from about there to about there, it's about 401 nanoseconds, which is bigger than the maximum. So if we go a higher frequency, it starts triggering until it stops triggering. Let's try this again. So that's about 95 nanoseconds. And we'd set 100 nanoseconds as our minimum. So we can trigger on a range. And as I said before, we have a number of other choices. You could play with them. Finally, I'd like to talk about the digital inputs. With the scope, you'll find two CS548s. These are the isolated digital input pods. We can use them for qualifying an analog signal or triggering off digital signals. Let's do some of that. First of all, to see the digitals, you click View Digital Inputs. There they are. I've only plugged one pod in. They have 4 inputs each, and I've plugged it into pod 1, which gives us input 1 to 4. So I'll turn these off. So we just have the 4 of them. You can give them names using settings, digital names and colors, and write in your own names and change the colors. I've connected it up to a box, which means you can go from a 0 to a 1 by flipping a switch. The digital pattern can be used to trigger. So I'm going to use input 1 and go on a rising trigger. Change this to be digital trigger and set it to triggered and flip the switch, and you can see that we triggered on the rising edge of input 1. Secondly, we can have a pattern. So I could make a pattern which is, say, 1 0 1, and I'll go back to using the analog, and at the moment we have got input 1 as high. I'll make input 2 high, input 3 as low, and input 4 as high. So we've got our pattern 1 to 4. If I change back to digital trigger and flip, it works. If I change one of the other inputs to something different, I'll just show it to you. I've made input 2, instead of being a 1, it's now a 0. So I'll change this back to digital trigger and flip 1, nothing happens. It needs the pattern to work. So I'll make that 1 again, and now it works. You can use the digital pattern to qualify the analog signal as well. We'll change this to an X, meaning not needed, and we stay with the 101, and we say digital pattern required, and it's capturing. Now I change the digital pattern and it stops working. Change the digital pattern back to what it should be, and it works. You can see this as a single capture. I'll change it so the pattern is incorrect. Do a single capture. There we see the change from 0 to 1 in the digital pattern, and then the trigger will have happened. There's the trigger at -580. There's the change which allowed it to happen. So that's digital triggers and the end of this little tour. Thanks for watching.